There's no coefficient here, so it's we don't have to kind of worry about this multiplication in front of here because there's no coefficient. But we do know that it's going to be x to the seventh power, one more, and then divide by 7, so 1/7, and then our ever-present plus c constant. Did you do better this time? Did you remember it? Or are you just on a roll and you're like, I don't know what you're talking about. I never forget plus c. Moving on. E. When we find the integral, it's just like when we find the derivative in regards to the fact that when there's multiple terms, we can just kind of break it up and deal with each term individually. If it seems super stressful because there's a lot going on, just put on your blinders like a horse, right? Keep it focused, don't get spooked. And just look at that. How do I find the integral of 6x? Oh, okay, well, that's 6 times, and then my x is going to become squared, and then I divide by that 2. Fantastic. And then find the integral of 2. Okay, well, that's 2. And then I've got x. And since this was x to the 0, now it's going to become x to the 1. And it's going to be 1 over 1, but that seems extra, but whatever. And then I just have my plus c. Maybe some of you are wondering of do I need to do plus 2c or do I need to do c plus c or c times c because there's multiple terms going on? No. C is just there as this placeholder of a constant. So if it is 2c, it's really just c. It's this idea of there's a constant here and we don't know what that constant is. And so when you have multiple terms, it's just at the end, just always just c. That's it. It's just this idea of a placeholder of a constant that we don't know what it is. Multiplying some of these pieces out, 6 times a half is 3x squared plus 2x plus c. And that is your integral for a 2-term polynomial. I would like for you now to try that out on your own with part F. Eight is going to be in the front. T is going to now be raised to the third power, and it's going to be 1 divided by 3 plus 5 in the front. T now becomes squared, and it's 1 over 2, and then plus c. 8 thirds t cubed plus 5 over 2 t squared plus c. Try G on your own. A is going to be in front like we did with all of our other constants, kind of this idea of a placeholder, right? X is going to become cubed 1 over 3 and then plus c at the end. So you can say this as a over 3x cubed plus c. Try H on your own. This one was a little bit of a doozy because you've got 3 terms now instead of 2, but still put your blinders on, focus on one thing at a time. 8n to the negative 3, also tricky because of negatives, right? So we get 8 times, and then remember that we're adding 1 to the exponent, right? So negative 3 plus 1 is going to become negative 2. I know a lot of our like instincts are now like, oh, negative 4, boom, next, right? So just remember that, okay, if I'm finding the integral, I'm adding 1. And so with negatives, that means that this is going to become negative 2, which means that I divide by negative 2. Plus 5, okay. Well, n now is going to become to the negative 1 plus 1 on that negative 2, and then I divide by negative 1 plus 3n. Now, hopefully we can start establishing that like ritual of when we were finding the derivative of like 8x, you're like, oh, it's just 8. It's just 8, right? And so now when we're finding the integral of 3, we're like, oh, it's 3x, right? We're just adding on the variable. We're just putting it back there. And then plus c at the end. Combining a few of my coefficients here, that would be negative 4n to the negative 2 minus 5n to the negative 1 plus 3n plus c. You could leave it like that, as always, or you could put it into fraction form. I'm going to put it in fraction form so we can kind of compare, because notice we've got fraction stuff down here. So I'm going to do negative 4 over n squared minus 5 over n plus 3n plus c. This is as good a time as any to remind you that when our exponents, when there's no parentheses around these guys, that exponent is only being applied to n, right? Not to the -4. So the -4 would not go in the denominator because -4 doesn't have -2 applied to it. It's only applied to the n. E basta. We're going to do these last two together because they're a little bit trickier, but we can totally handle it using some of the tricks that we learned in derivatives and also just putting blinders on, staying focused, remembering what we know. Finding this integral, I'm going to first turn it into a form that I like to deal with. I like it when it's everything in one row. When I'm dealing with the power rule, I want it to all be just with powers, and that's it. So with that, I can change this to the integral of 5x to the -2, a beautiful example of that -2 is only being applied to x, right? And not to the 5. So that's why that works like that. And then plus 3x with regards to x. Now I can go ahead and apply that. It's 5, and then we've got x now to the -1, so 1 over -1 plus 3 times x is now to the 2, 1 over 2 plus c. Notice that I do things backwards from when we were finding derivatives. I always did the coefficient first and then dealt with the exponent. Now I'm always dealing with the exponent first and then dealing with the coefficient. It, for me, is a way to always keep straight this like rhythm or dance or song almost in my head that I like, okay, first up in the exponent and then deal with this, right? Like this like step process that I go through when I'm finding the integrals, that it's this, I know I sound crazy, but it's like this song that happens when you're doing mathematics. You could leave it like this, or you could put that x back in the denominator. Remember when we dealt with fractions that looked like this and we were trying to find the derivatives? This was like 2 units ago. And we didn't like that it was one big fraction. We wanted to deal with like tiny little terms. So focusing on things that you don't like instead of being like, oh, like instead of stressing out about it, what you can do is be like, what do I not like about it? Lean in, focus. What do I not like about it? I don't like that there's this up here in the numerator. I don't like that it's big and chunky. It stresses me out. It freaks me out. So I'm going to break it up into small pieces. Well, how do I do that? I do that by doing x over x to the 4th plus 200 over x to the 4th with regards to x. I can simplify this down just a little bit. X over x to the 4th becomes 1 over x cubed, right? This x in the numerator cancels out with one of the x's in the denominator, and then plus 200 over x to the 4th with regards to x. Now it's kind of separated out that it looks similar to this, right? You feel slightly better about getting it to this place because then you're like, oh, then I can just put that up, deal with my negative exponents, the integral of x to the -3 plus 200x to the -4 with regards to x. Now I can find my derivative or my integral. Adding 1 to my exponent and then dividing by that guy. Adding 1 to my exponent and then dividing by that guy, and then plus c. So this becomes -1/2 x to the -2 plus 200. Let's do it all in one foul swoop. Realize that x to the -2 will go in the denominator with 2, right? If we thought about this as being x to the -2 over 1, right? Those guys just flip. And so those guys just flip. So then that x squared is going to go with the 2. So I can do -1 over 2x squared. This negative right here is going to make this a subtraction. 200 over, and then it's 3 still in the denominator. And then now this x cubed will join it there. And then we still have plus c. So notice from this move to this move, um, um, your thought process here, like I think a few of you have figured out how to find the derivative when it's in this form without having to convert it into negative exponents. Like you figured out a pattern of like, oh, I know what the pattern is here with the power rule. When I'm finding my derivatives, there's that similar opposite pattern with finding the integrals in regards to that. So if you're one of those people who had a shortcut, you can still apply that shortcut here with the integrals, just in an opposite way. All right, that's all we're doing for our notes today. We're going to move on to solving for C. How do we solve for C? We're also going to move on to, as you can see, some word problems. So good job today, guys. We're doing it. We just learned integrals. Fantastic.